You can calculate the mass of one of the products if you know the mass of one of the reactant and vice versa. So if you know the mass of one of the products, you can also calculate the mass of the reactant. For example, if you want to calculate the mass of the product, which is aluminum oxide, that is formed when 135 grams of aluminum is burned in air. So now we know the mass of one of the reactant, which is aluminum, and we need to calculate the mass of the product, which is aluminum oxide. The first thing we need to find is the relative atomic mass of the different elements within these compounds or within these substances. So aluminum, the relative atomic mass of aluminum is 27, oxygen is 16, and we're going to use the relative atomic mass of oxygen to calculate the relative formula mass of the product, which is aluminum oxide. To do this calculation, we need to follow certain steps. The first step is to write out the balanced equation. So you cannot do any calculations without writing the balanced equation. The balanced equation is that for aluminum, react with 3 moles of oxygen to give you 2 moles of aluminum oxide. The second step is to work out the relative formula mass of the reactant and the product you want. So the relative atomic mass of aluminum is 27, and we need to calculate the relative formula mass of the product we want to calculate its mass, which is aluminum oxide. When we do the calculation, you're going to find that it equals 102. The third step is to find the number of moles of the substance you know the mass of. So we know the mass of aluminum, and we can use the formula triangle to calculate the number of moles. So number of moles will equal the mass over the atomic mass or relative atomic mass of aluminum. So number of moles of aluminum that have been reacted, which is equivalent to the 130 grams, is 135 divided by the relative atomic mass of aluminum, which is 27. So there are 5 moles. So 5 moles of aluminum have reacted. Now we will use the balanced equation to work out the number of moles of the other substance or of the product, which is the aluminum oxide. So we've seen in the balanced equation that 4 moles of aluminum gave you 2 moles of aluminum oxide. So if 5 moles of aluminum reacted, that will give you 2.5 moles of aluminum oxide. The final step is to calculate now the mass of the product, which is the aluminum oxide, using the formula mass of that product or of that substance. We will again use this triangle, the formula triangle, but we need to find the mass now. So the mass will equal the relative formula mass times the number of moles. So N times mR, which is 2.5 times 102, so it equals 255 grams. So when 135 grams of aluminium is burned in air, that will produce 255 grams of aluminium oxide. But that's assuming that 100% of aluminium actually reacted and burned and gave you 100% of the product, which is aluminium oxide. So this is assuming 100% yield of our product.